Share with you two Scratch projects I made as part of a sort of joint maths computing investigation into what numbers you get when you roll two dice. This is the first Scratch project I made. Very simple one. Code's on the website. You've got two characters here. If you click on the crab, it will roll one dice. So we click on him. He asks you how many dice you want to roll. Let's say we're going to roll 1,000 dice, and it will show you over here the distribution of what scores you get. And as you'd expect, you get roughly the same number of ones, twos, threes, fours, five, and sixes. You can go really large with this as well. You can have really, really big numbers. So we can put 10,000 in. We're going to roll the dice 10,000 times, and you'll see the more dice you roll, the more even that distribution gets. If you click on the lobster, however, the lobster is going to roll two dice. So let's roll two dice 10,000 times and see how quickly this works on the Scratch website. There we go, it's done it. It runs a little bit slower if you're running it just in Scratch 1.4. It's quite nice to watch it happen. Anyway, there we go. So it's rolling 10,000 dice, and you'll see the distribution here is very, very different. And you should notice that you get more sevens than any other number. I then made a new version of this project. We go over here, we'll have a look. This one uses Turtle Graphics to actually plot a graph. And with this one, you click on the green flag to reset it. You can roll one die. If I roll it, say, 1,000 times, we should see the numbers start to move along, plotting a chart, and you'll see that roughly they're in the same place. It does look like, oh, mind you, yeah, 6 is leaping out in front. But you'll find that if you do bigger and bigger numbers, you'll get a more even distribution. So let's try that again now. We're going to roll both dice. So if I click on the green flag to reset it, and I'm going to roll both dice, I'm going to roll it. It works well up to about 2,000 times. So I'm going to roll 2,000 rolls, and we should see fairly early on now, one's not moving at all, obviously, because you can't roll a 1 with two dice. And we should see the numbers in the middle getting into a lead fairly soon. I'm expecting all 6s out in front. I'm expecting 7 to win this particular race, though. So we'll see who wins in a moment. Is 7 going to catch up? It really ought to. So come on, 7, you can do it. So anyway, it's quite nice use of Scratch Turtle Graphics to actually plot a bar chart. Let's see how it gets on. We're about halfway through now. I've got the bottom right hand corner, I've got the roll number, just over 1,000 now. Still expecting 7 to catch up. You could use this as a discussion as well about what actually makes a random number. How do computers generate random numbers? You can think about how much easier in a way it is for humans to generate random numbers. We could think of a number, but then is that going to really be random? We can just roll dice, which is pretty random if you roll enough of them. But you can get thinking about how does a computer create a random number. And here we go, we're coming up to 2,000 rolls of the dice, and as I predicted, number 7 came out in front.